Welcome to another episode of Beyond the Basics, a reference guide for mathematics. This is episode 8, multiplying positive and negative numbers. We're going to start by discussing what it means to multiply. Then we're going to look at multiplying on a number line, and then multiplying by groups, and we're going to look at the rules of multiplying and ways to help you remember them. What is multiplication but repeated adding? Adding the same number over and over again. So 3 plus 3 plus 3 plus 3 plus 3 over and over again. Multiple times. That's where the term times come from, like 3 times 4 is because 3 happens 4 times or multiple times. So this is looking at multiplication as repeated groups. Repeatedly adding positive numbers where we're going to start, because we're going to start from a place you already know. 3 times 2 is 6. Why? Because you have 3 groups of 2. Why? Because on the number line, when you see 3 groups of 2 stacked on top of each other, you get 6. That's why. You can also reverse it and look at 2 times 3 being 6. So you have 2 groups of 3. 2 groups of 3 is still 6. So either 3 groups of 2 is 6 or 2 groups of 3 is 6. That's what repeatedly adding is. That's what multiplication is. What if you repeatedly add negative numbers? Like 2 times negative 3. I have down that it's going to be negative 6, but why? Because 2 groups of negative 3 is what you're adding. And if you stack them together, they go down to negative 6 because they're negative numbers. If I switch it and have 3 times negative 2, it's still negative 6, because now you have 3 groups of negative 2. Negative 2 plus negative 2 plus negative 2 is negative 6. What if you have negative first? Like this. Negative 3 times 2. I still have it down as negative 6, but why is it negative 6? Well, it means negative 3 groups of 2, but what's a negative group? What about this one? Negative 2 times 3 equaling negative 6. I still have that one as negative 6 also. So we have negative 2 groups of 3 this time. But again, what are negative groups? Well, I could explain negative groups, and I will explain negative groups eventually. It's a little bit more complex in this particular model with the number line. So I want you to consider that multiplication is commutative, meaning that you can reverse it and get the same answer. So just like on the slide previous, 3 times 2 was 6, but 2 times 3 was 6. That's true for all multiplication, even with negative numbers. So if we commute negative 3 times 2, we get 2 times negative 3, and that's still negative 6, just as the dot shows you. And if we reverse or we commute negative 2 times positive 3, then we have positive 3 times negative 2. Watch the dot again. 1, 2, 3 groups of 2. You still landed at negative 6. So you can use the commutative property to understand that when you have one negative factor, your answer is going to be negative. So what if they're both negative? I always get that. When you teach middle school, they do that a lot. So what's the opposite of that? Like negative 2 times negative 3, you mean? Why, that's positive 6. Why, you ask? That's always a good question. Asking why is not a bad thing. That means you have negative 2 groups of negative 3. But again, what's a negative group? Well, negative means the opposite of something. So if you've ever seen a negative on a photograph, like the negatives when you had film, and you held them up to the light and the colors were weird, the colors were the opposite color on the color wheel. So your reds would be greens, your blues would be orange, and your purples would be yellow, and your blacks are whites, and so on and so forth, blended in. Negative means the opposite. So we're going to look at it as the opposite of 2 groups of negative 3. Well, we already know that 2 groups of negative 3 is negative 6. Thus, the opposite of it would be positive 6. So negative 2 times negative 3 is the opposite of 2 groups of negative 3, so it's positive 6. Looking at the last one there too, negative 3 times negative 2, also positive 6. because those same negative groups are still the opposite of negative 3 groups, or the opposite of 3 groups of negative 2. And we already saw that 3 groups of negative 2 is negative 6. The opposite of that is positive 6. Let's write this down in our notebooks before we move on. Pause as you need to. So I didn't do the negative times a negative in our number line notes. We'll get to that later on in the notes. So the title is Rational Numbers, Integers, and we are multiplying. To multiply means repeated adding. And there are 2 of our examples. Our positive example, 3 times 2, meaning 3 groups of 2. So you have 2 plus 2 plus 2, which is 6, and then I showed 2 plus 2 plus 2 on the number line. That's the first example, so I boxed it in green. And then 3 times negative 2 is negative 2 plus negative 2 plus negative 2, which is negative 6, and I showed that on the number line. So we're looking again at our bowl of soup and our fire and our ice. Looking at one we already know, 3 times 2 is 6. That means 3 groups of 2. So here's our 3 groups. Inside are 2 fires in each group. So you can see that you've got 2 repeated 3 times, or 2 plus 2 plus 2, which is 6. What if I reverse it and I have 2 groups of 3? Well, I just have 2 circles that time, and inside each circle is 3 fires. I still have 6 fires, so the temperature of my soup has still gone up 6 degrees. It's the same thing, but this time it's 3 plus 3 is 6. Let's throw some negatives in there. Why not? 3 times negative 2 means you're going to have 3 groups of negative 2. So here's my 3 groups, and the fact that they're positive means that what's inside them will remain as it is. So I put 2 ice cubes in each one. My temperature of my soup has gone down 3 degrees because I've added negative 2 plus negative 2 plus negative 2, which is negative 6. What if we have 2 groups of negative 3? 2 groups this time, but in each group you've got 3 ice cubes. The temperature has still gone down 3 degrees. You have only added ice. Your temperature is going to go down. And that's like negative 3 plus negative 3, which is negative 6. Here's where we get to the negative groups. It's interesting. So we're going to start with this one. 3 times 2 is 6. We know that. Here's that model. What if we have negative 3 times negative 2? Well, then both of those things are going to be negative. We will have negative circles, negative groups, and we will have negatives in each group. Well, the negative circle is a negative group, meaning it's going to go to the opposite of what's inside. So that is a negative negative 2, and so are the other 2. That, my friends, is a double negative. It is a negative negative 2, or it is the opposite of negative 2. What happens when we add all those double negatives? Well, negative negative 2 is positive 2, because it's the opposite of negative 2. So they're all positive 2, and 2 plus 2 plus 2 is 6. So if 2 plus 2 plus 2 is 6, negative negative 2 plus negative negative 2 plus negative negative 2 is also 6. That's one way to explain negative times a negative is a positive. Let's write it in our notebooks. So this time I'm titling it grouping, and we're going to start with 3 times 2 equaling 6. The 3 is positive, so we first draw 3 positive circles. Inside those circles, we put 2 positive signs because our second number is 2. So 3 groups of 2. That means the model is showing 2 plus 2 plus 2, which is 6. Now our next example, we still have positive 3, but this time we have positive 3 times negative 2. So inside each circle, we put 2 negatives. So we've got negative 2 plus negative 2 plus negative 2. So you've got negative 2 repeating 3 times. That means you've got an answer of negative 6. Well, what if the first number is negative? You could think of it as the commuting like we did in the previous slide and just switch it and look at 2 groups of negative 3. But you can also look at it as negative groups. And our negative groups make what's inside its opposite. So you put 2 positives inside each one of those negative groups. It means it's the opposite of positive 2. The opposite of positive 2 is negative 2. So you really have negative 2 plus negative 2 plus negative 2, or the opposite of positive 2 plus the opposite of positive 2 plus the opposite of positive 2, meaning you have 6 negatives. What if they're both negative? That's a good question. Always ask good questions. You still have your negative circles, which turns everything inside them to their opposite. So this time inside those circles, you have 2 negatives, because you have negative 3 times negative 2. So 3 negative circles with 2 negatives in each circle. So you have the opposite of negative 2, which is negative negative 2 plus negative negative 2 plus negative negative 2, just like on the other slide, or 2 plus 2 plus 2, which is 6. Now we're going to take a look at this using rules. Rules really work for some people, and they are a great way to help you remember what the answer should be. With multiplying, your multiplication stays the same. 3 times 2 is 6, whether it's 3 times positive 2, 3 times negative 2. It's still going to be 6. The negatives only change the polarity of your answer, so it will only change it to positive or negative. Rule number 1, if you're multiplying 2 factors with the same signs. So if you have 3 times 2, they have the same sign, they're both positive. That's positive 6. And if you have negative 3 times negative 2, those are both negative, they have the same sign, so it's positive 6. So one rule you could think of is multiplying 2 factors with the same signs yields a positive product. What if you're multiplying 2 factors with opposite signs, like negative 3 times 2 and 3 times negative 2? Well, both of those answers are negative. Negative 6 on both of them. Multiplying factors with opposite signs yields a negative product. That is sometimes the rules I use, but I prefer the rules on these next pages, because when you get higher up in math, you will have things like exponents, more than 2 factors multiplied each time. So you need to start to kind of expand that thought. What if there's more than 2? If they're all negative, does it make it positive? Let's look at that. An even number of negative factors. So we're looking at odds and evens this time. Evens are things like 0, 2, 4, 6, 8, 10, 12, so on and so forth. 3 times 2 is 6. Well, there aren't any negative factors there. That's right. 0 is an even number. And negative 3 times 2 is also positive 6 because it has 2 negative factors, and 2 is also an even number. Both of those have positive products, because multiplying an even number of negative factors yields a positive product. What about odd? Well, you've probably already guessed it. If you have an odd number of negative factors, like negative 3 times 2 and positive 3 times negative 2, both of those answers are negative. So there was only one negative factor. 1 is an odd number, so your answer is negative. Multiplying an odd number of negative factors yields a negative product. These rules come alive more so when you have more than 2 factors that you're dealing with. Let's take a look at that. Once again, we're looking at an even number of negatives, but this time we have more than 2 factors. So here we've got 4 factors: negative 3, negative 2, negative 1, and negative 1. All 4 are negative. That's an even number of negative factors, so the answer is positive. Here's how it works. Negative 3 times negative 2, that's positive 6. Positive 6 times negative 1 is negative 6. Negative 6 times that last negative 1 is positive 6, because a negative times a negative is a positive. What about exponents? You remember exponents. It does not mean negative 3 times 2. It means negative 3 times negative 3. 2 negative 3s is what it means. 2 is an even number, so negative 3 times negative 3 is positive 9. Negative 3 to the 4th power is negative 3 times negative 3 times negative 3 times negative 3. Again, you have 4 negative factors, meaning your answer is positive 81. Here's some examples of odd number of negative signs. So if only one of your factors is negative, then your answer is negative. And if you have 3 factors that are negative, because 3 also is an odd number. Negative 3 times negative 2 is positive 6. Positive 6 times negative 1 is negative 6. Negative 3 to the 1st power means you have only one negative 3 as a factor, so it's negative 3. Negative 3 to the 3rd power means you have negative 3 times negative 3 times negative 3, so you have 3 negative factors. That's going to give your answer a negative answer, because negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is negative 27. So again, multiplying an even number of negative factors yields a positive product. And multiplying an odd number of negative factors yields a negative product. Let's get that written in our notes. This time I'm going to show you our third model, which is kind of embedded in our notes for the rules, and that's the model of patterns. So if you look here, the pattern is the 2, the 1, and the 0. And then you have 6, 3, 0. Your products are going down by 3 as that second factor is going down by 1. What do you suppose the next equation would be? That's right, 3 times negative 1. Well, we can use the other products to figure out what the next answer in that pattern would be. 6, 3, 0. We have to go 3 below 0. And that's going to be negative 3. So there you can see the finished work of that pattern. 3 times negative 1 is negative 3. 3 times negative 2 is negative 6. That's why a positive times a negative is a negative, which we've already proven 2 other times. So now I took that last one, 3 times negative 2 equals negative 6, and I'm going to start another pattern in the next column. Here's this pattern. This time the first factor is going down by 1 each time. The next equation in the sequence is going to be negative 1 times negative 2 because you have 3, 2, 1, 0. 1 below 0 is negative 1. So now we have a negative times a negative. But look at what's happening to the products. Negative 6, negative 4, negative 2, 0. Is that going up or down? Be careful. They're negative. Think of them as temperatures. If the temperature went from negative 6 to negative 4, did it go up or did it go down? It went up. It went up by 2 because they're negative. So they're already below 0. So when you get to a smaller negative, you're actually going higher. So to figure out what negative 1 times negative 2 is, we have to go 2 higher than 0, and that's 2. And here I went a little bit further on that one. In these two patterns, I have illustrated all of the rules for multiplying integers. The first one you already knew. Positive times a positive is a positive. All of those are right there in the first pattern. But then notice I didn't box the 3 times 0 is 0. I could have boxed the 3 because it is positive, but 0 is not positive, nor is it negative. So I didn't box it at all. If you look at that equation that I did box, you have 3 times negative 1 is negative 3. That's an illustration of our next rule, that a positive times a negative is a negative. And you can reverse that and say a negative times a positive is also a negative because of the commutative property. And those are all here. And then if you go beyond the 0 times negative 2, you have a negative 1 times a negative 2 equaling a positive 2. And that's an illustration of the last rule, that a negative times a negative is a positive. Those are our 3 rules for multiplying integers. Those are the ways that you can remember it. Either a positive times a positive is a positive times negative is negative, negative times negative is positive, or you could remember the even and odd rule. If you have an even number of negative factors, your answer is positive. If you have an odd number of negative factors, your answer is negative. Here's what my notes look like finished. You can add color and designs as you like to make your pages happy. Or if you like them plain and clean, you can do that as well because it's your notebook. Writing in your notebook is to help you remember things. And writing things down, just the act of writing it down, is a great memory tool. Thanks for watching, and I'll see you in the next video.